In this video we are going to learn equation of an ellipse, and we are going to deal about this equation: x squared over a squared plus y squared over b squared is equal to 1. This is the canonical equation of the ellipse. Here we will understand with the exercise better, I think. If you remember, the AA prime was equal to 2a, AA prime was equal to 2a, and this is the major axis now because it is the longer one, and BB prime was equal to 2b. So 2b is equal to 8, it's going to be. And if I solve this one, 2a is equal to 12, a is going to be equal to 12 over 2, a is equal to 6, it's going to be. And b is equal to 8 over 4, 8 over 2, sorry, the answer is 4, 8 over 2, and b is equal to 4 is going to be. So now if I know the a and b value, and for this function I can write, for this graph I can write the canonical equation: x squared over a squared plus y squared over b squared is equal to 1, it's going to be. This implies that x squared over 6 squared plus y squared over 4 squared is equal to 1. This is the canonical equation. Only we can continue one more step. X squared over 36 plus y squared over 16 will be equal to 1, and this is our form. Okay, only I want you to remind about what are the places of a and b values. The length from the origin to the vertex point, this is 6, so this point is 6, and this point was 4, and this is minus 4, and this is minus 6, it's going to be if the center is origin. Okay, let's continue with the other question. X squared over 36 plus y squared over 25 is the equation of the ellipse, and it is asking all these values: the length of major axis, the length of minor axis, eccentricity, distance between the foci. Here it seems that a is the longest value because the square root of it 6, and the square root of it's going to be 5. So with respect to this one, this is the longer one. That's why the x value is the major, x-axis is the major axis, y-axis is the minor axis, it's going to be. Okay, so this is equal to, from the previous lesson you remember, this is equal to major axis 2a, it should be. The length of minor axis, it's going to be equal to 2b. And eccentricity, the formula was c over a. The distance between the foci, it's equal to 2c. And the coordinates of the vertices of the foci we are going to find when we find a and b values. And the directrices, if you remember, x is equal to plus or minus a squared over c was the formula. Okay, let me continue with this question. Firstly, x squared over the formula, x squared over a squared plus y squared over b squared, it was equal to 1. So a squared here, it's equal to 36, and a is equal to 6 plus minus 6, we can say, and b is equal to again plus minus 25. B squared is equal to 25, b is equal to plus minus 25 plus minus 5, it's going to be, sorry. Continue with the values here. 2a, it's easy for us. Let me change the color. And a, the first one is 2a length. I should find. I know that a is equal to 6, so 2 times 6 is equal to 12, it's going to be. And b is equal to the minor axis, it's equal to 2b. b was the 2b, which is equal to 2 times 5, that's equal to 10, the length of the minor axis. Okay, the eccentricity c over a, which is equal to, for the c over a, I need to find the c value. Since a is bigger than b, the equation of the ellipse, it's going to be a squared is equal to b squared plus c squared. So a is here, it's equal to 6, 6 squared is equal to 5 squared plus c squared, 6 squared is equal to 36 is equal to 25 plus c squared, and 11 is equal to c squared, so root of 11 is equal to plus minus root of 11 is equal to C. And the eccentricity positive one we should choose. C over A it's going to be, which is equal to root of 11 over 6, which is equal to, actually we cannot simplify these are, so the value it's going to be root 11 over 6. Okay, the D1, the distance between the foci, it should be 2C. D is 2C, distance between, which is equal to 2 times root 11, which is equal to 2 root 11 is going to be. And the coordinates of the vertices and the foci. Here, since the A value is bigger, the foci, foci are on the x-axis, and the distance between them is root 11. Firstly, here it's going to be 6, minus 6. I think the value is minus 1, minus 2, minus 3. Yes, minus 6 is this point, and the 6 is here. This is the 6, and the coordinates I'm going to write at the end the coordinates. The value is 5 here. 1, 2, 3, 4, 5. This is the another coordinate, and I'm going to get a bit down here to see the whole graph. Minus 1, minus 2, minus 3, minus 4, minus 5. This is the last point that we are going to find. This is the minus 5, and here it is 5. Total length is 10. Okay, let me, I brought here before the figure like this, and I'm going to connect the vertices now like this. Here it's 6 and minus 6 plus 6 and minus 6. Here it is 5 and minus 5. This is the figure of our ellipse. Yes, we should find the place of the root 11. Root 11 between root 9 and root 16, which means between 4 and 3. So it should be firstly on the x-axis, because the major axis is this one, that one. And between 3 and 4, it's going to be here, approximately here. So this is this point, if I choose like minus root 11, and this point is plus root 11, it's going to be, and it's asking to find the coordinates. So if I write for all of them the coordinates, I'm going to use different color again for that one. This point is minus 6, 0. This point is 0, 5. This point is 6, 0. This point is 11, 0, root 11, sorry, 0. This is minus root 11, 0. And this point is 0 minus 5. It's going to be this point. Okay, the last value now I need to find the directrices. Directrices is a square over c, which is equal to the this is f. I'm sorry, f x is equal to plus and minus a square over c, which is equal to 6 square plus minus 6 square over root 11. X is equal to plus and minus 6 square is 36, 36 over root 11 it's going to be. If it is approximately 3 or between 4, the value it's going to be between 12 and 9 approximately. The value is between 12 and 9 it's going to be. So the directrices, you know, you remember from the previous lesson, here it's going to be, or on the other side is going to be. Okay, let's continue with the other question. This question and the previous question, they are similar to each other, only this form is not direct canonical form. So first we are going to transform this form into canonical form, and then we are going to find all the values. And the major axis here, it's going to be, it may be different, as I see from the figure before I put, it means that the y value is the bigger one, so the y-axis is the major axis. It may be, let's see that one firstly. Then all the asked things, they are same. So the formulas in the previous page I wrote, I'm not going to rewrite them again. Only first I'm going to change this one into canonical equation. In the canonical equation, x squared over a squared plus y squared over b squared was equal to 1. So with respect to this one, x squared over the result, it should be 1. So I'm going to write 16x squared plus 9y squared when it's equal to 144. If I want at the end, I mean on this side 1, I'm going to divide both sides by 144. So I'm going to divide by 144 this side, and I'm going to divide 144. Also in equations it is possible if you are not dividing by 0. So this is 16x squared over 144. You may separate the denominators, you may give to different numerators. For this 144, for this 144, which means 9y squared over 144. Now this side it's going to be equal to 1. As you see now, it seems now more canonical equation, only we don't have here x squared over a squared. But when we simplify these two, it's going to be 144 is 16 times 9. So when you divide 144 by 16, this side it's going to be 9. I mean the down part is 9. This is 1 and this is 9. And when you divide them, this is 16 and this is 1 it's going to be. So the equation is x squared over 9 plus y squared over 16 is equal to 1. Yes, now this is the canonical equation. So a squared is equal to 9 and b squared is equal to 16, and a is equal to 3 plus and minus 3, and b is equal to plus and minus 4 it's going to be. Since b is the bigger value, b is bigger than a, the major axis it's going to be 2b. 2b is the major axis, and the minor axis it is 2a is going to be. What is the eccentricity? It's not going to change, c over a. Actually here the major axis, since the major axis is b, it's going to be c over b. And the distance between two foci, the foci, they are going to be again it's 2c, but they are going to go on the y-axis. And the coordinates of the vertices of the foci we are going to find now, and the directrices it's going to be b is equal to y is equal to plus and minus b squared over c is going to be. Okay, this part is important. Okay, let me find the values now. I'm going to continue with the major axis. It's equal to 2b. 2b I found that's equal to 4. So 2 times, this is the length also. 2 times 4, which is equal to 8. And b, the length of the minor axis, 2 times a this time. It's going to be 2 times 3, which is equal to 6. And the length, the eccentricity, it's c over a, so I need c value here. Let me find the c value here. I will find it down. A squared plus, and since b is bigger than a, b squared it should be equal to a squared plus c squared, and b is equal to 4 squared is equal to a squared 3 squared plus c squared, and it is equal to 16, 9, and here c squared. 7 is equal to c squared. C is equal to root of plus minus root of 7 going to be. So with respect to this one, since c is equal to root of 7, if I return to the question here, and the value is c over b, eccentricity is c over b, so the third value c over b, which is equal to root of 7 over b is equal to 4, is going to be. You cannot simplify, that's why I am going to continue. Distance between two foci, that's the d1, 2 times c, which is equal to 2 times root 7, which is equal to 2 root 7 is going to be the coordinates of the vertices and the foci. Here is the I'm going to show again on the graph to explain better. Firstly, the lengths are 4 and minus 4, so 4 and minus 4 I'm going to locate like this. Minus 4, I think I put to minus 5. Yes, I put to minus 4. The minus 4 it's going to be here. Let me clean the down part not to mix. Yes, okay. Then this point it's going to be minus 4. The values are 3 here, and this point is going to be minus 3. So our figure it's going to be something like this. If I put the origin, the center is at the origin. In canonical equation, center it should be at the origin. That's also important. Here to this side, then to this side. Here is our ellipse, and the coordinates. If I'm going to write at the coordinates, let me write here. The coordinates, sorry, it's going to be here the coordinate is 0, 4, here 3, 0, here minus 4, 0, minus 4, and here minus 3, 0. Again, I'm repeating, since the major axis is the y-axis, the foci they are going to be on, foci are on y-axis, and the root 7 between 3 and 4, root 7 between 3 and 4, root 9 and root 4, so pardon, root 9 and root 4, which is between 3 and 2, and the foci approximately here it's going to be, this is root 7 and this is minus root 7, and the coordinate is root 7, pardon, the y-axis, it is on the y-axis, 0 root 7, and this is 0 minus root 7 is going to be. Okay, the last part is the directrices. The f is the directrices, which is equal to plus minus y is equal to plus minus b square over c, which is equal to b square is equal to 4 square, which is equal to plus minus 4 square over root 7, which is equal to plus minus 4 square is equal to 16, plus minus 16 over root of 7 is going to be. Approximately the value is 2 point something, so it's the directrices, they are going to be at 8 and minus 8 approximately, or 7 we can say. Okay, so y is equal to plus and minus root of 16 over root 7. They are going to be the directrices of the here, and directrices they are going to be parallel to x-axis approximately. Here it is, pardon, couldn't draw well. Here it should be like this, and the other one it should be down part, and it should be symmetric with respect to origin. Okay.